Okay, example number 5. A 0.174 kilogram softball is pitched horizontally at 26 meters per second. The ball moves in the opposite direction at 38 meters per second after it's been hit by the bat. Draw arrows showing the ball's momentum before and after the bat was hit. Okay, so first reminder, momentum is equal to mass times by velocity. Velocity is a vector, it has a direction component, so does the momentum. Okay, so whatever direction the vector is for velocity, it will be the same direction for momentum. Now, we can draw that. We should maybe draw a picture to even see what we're talking about here, because if we want, okay, so there's the batter. We have the ball going this way initially, right? And we got to decide if we're going to call that positive or negative. I would say maybe negative x direction and then positive. So velocity initial is this direction, momentum initial is that direction. And then after the interaction with the bat, velocity final, it's going the opposite way. We don't know what it is in comparison to that. And then we have our momentum final. Okay. We can run those numbers though to find out. What is the change in momentum of the ball? And we know the mass and we know the velocity. Okay, so change in momentum is momentum final minus momentum initial. And momentum is mass times by velocity. And we have our initial component, or sorry, our final component subtracted from our initial. And we know all of this. We know the mass. We know the velocities. We could factor out that m2, meaning like we can do mass because it's the same mass. Velocity final minus velocity initial. Okay. And we're calling, make our list here really quick. Mass is 0.174 kilograms. Velocity initial, pitched horizontally at 26 meters per second, and we're saying it was negative initially, so negative 26 meters per second. Oh, that's 3 sig figs. And then our velocity final is a positive 38 meters per second. Okay, so I'm going to plug all that in. So we're going to take mass, 0.174, and multiply that by the final, which is 38, subtract the negative 26. Okay, subtracting the negative 26. And so our change in momentum, we were working with 3 sig figs, so it's 11.1, and that's kilogram meters per second. And it's equal to delta P. Okay, nice. And then if the bat and softball are in contact for 0.8 milliseconds, what is the average force that the bat exerts on the softball? Well, we know that our change in momentum is equal to our impulse, right? Delta P is equal to force delta T. And we just solved for that. And now they've given us the time, and so we can solve for the force. So I'll divide that over. So we have delta P divided by delta T equals that average force. So it'll be 11 0.1 kilogram meters per second divided by the time, milliseconds. So we need to put that into seconds. That would be okay, milliseconds. So 11.1, I'll take the whole big number for my calculator, divided by our second component. So this is a force of 13920 newtons. We can do a unit analysis. We're doing kilograms meters per second divided by seconds, which is the same as multiplying by the reciprocal. And so we're left with kilograms meters per second squared, which is a newton. Okay, nice. We're going to skip this bounce impulse, and so that's it for notes today. We have your concept check and then the assignment.